Ooh, so, give a little time for this thing to actually start. Why is that not opening? So, docs. What? Everything is really slow on this computer right now. Okay, so while I got this system working, it's a little bit hacked, and so I was thinking a good thing to do might be to go in and try to make it a little less hacked. And I'll explain exactly what I mean by that in a second. Yep, that's across the boundary. That's why they're appearing in the middle. So, I was thinking I should do... well, that doesn't explain why they jump like that, though. Yeah. Oh, right. I remember this was a bug I noticed before. That in one direction they jump across, and in the other direction they don't jump across. So I've got some kind of bug. But anyway, so the whole animation system for these is just a little bit hacked together, and I thought maybe I would write down some rules for how it's supposed to work and make it work consistent with those rules. So let's have so let's define what this rule is. Let's draw a tile. About that big. So we have a tile that's this big. Let's move to the right. So what we want to do, Maybe I should use MS Paint for this, actually. And actually, better yet, let's use Photoshop. Where is it? So what we want to think about is that we have long ticks, which happen at a lower rate than the full ticks. Okay, so here's our thing. So what we want to do is say at tick 0, let's say that the objects appear here. Oh, that's pretty soft. Here. Wait, 1, 2, 3. No, that's not right. Here, and here. Like, let's say that that's the time equals 0 position for these. Actually, they should be down a little bit. Should be like this. And on the times off from this, they'll move to the right. And after 16 ticks, after a long tick, they'll reach the next spot. So we want some kind of systematic rule for how they're going to move. And what we're going to say, let's make them actually bigger, because they should almost touch. Okay, there we go. So here's what the objects look like, but then we just want to talk about where their centers are. Okay, so the center is here at time t equals 0. Let's put this on a separate layer. Oops. Okay. Now, if they're immobile, they don't move. They stay at the time 0 time position. This may be what the code is already doing, but at least I'll have like a rule. But if they're marked as moving, then over time, they'll interpolate to the right. And they'll trace out this kind of position. And this one will go like this. So this one, if we allow it to move, will actually extend out into the next tile, which is good. This one starts here and goes like this. So if we want it to appear anywhere further to the left, if we want its center to be here, it would have to actually be in the next thing moving over. So the only way that's going to happen is if there's a conveyor belt to the left facing right, so that this case happens and it'll push in. If it's being transferred from anything other than a conveyor belt, we'll just have it transfer all the way to exactly this point at exactly tick 0. So it exactly matches the thing. Now, this position doesn't work out correct left to right. It's still going to jump a little bit when something comes in from the side. If you look at where our center point is, it's 3 away from the edge and 2. So something coming in from the side would come down this center line and land here, and then it'll have to jump back. And similarly, it's going to come down here and jump forward to that. And that's okay. It'll scroll in smoothly up to that point. So hopefully that makes sense. I don't really have a good way to draw this. You kind of need a time diagram and to show like its position over time. I guess I could draw an axis thing. But you kind of want to see what the graphical correspondence is. Okay, so now I have like a really solid definition, and I think it's what I've already implemented, but the important thing is the rule about when a thing moves off the end of its thing. So let's start by disabling the tick. Except let's fill everything. So let's start with that. All right. So there's okay, there. It's in a weird state when that's forcing it. It's a confused state because every frame it kept repopulating it, which was confusing it. Yeah, now if I turn it on, it's fine. Okay, so if we rotate one, whoops, hit the wrong button. Okay, so if I rotate one, all right, they all seem to be in the right spot, pretty much where I drew them. They're a little inward more, so I'll push them outward again. So that part seems to be correct. Now let's force them to animate and see if they're animating through the phase I was talking about. So that we do by saying BR arrow mobile slots equals items. Did I return for that? Yeah, that's wrong. Continue. I guess that could work. It would only do it to the first one or something. Anyway. Okay, so yes, this seems to be doing exactly what I was saying. If they're allowed to go, then they go off the end. I'm not sure why they stop when I pick the new direction. I guess because the rebuild resets the whether they're mobile or not. Okay, so let's press them wider. I think I was trying to get the width correct while I had that bug where I wasn't drawing them at the right height either. So that's this one. That's this. That's this, right, okay. Right, I remember pushing this wider because I didn't like how it looked. Let's push it back. All right, I'm okay with that. And they will jump backwards, like I was saying. But that's okay. I can live with that, I think. We'll see. And then, I mean, I can always try making the belt 5 long and hope that those slot in better. Okay, so that is actually implementing we have actually implemented the thing I described. So, and they look correct in all directions. But now I have a clear rule. So when I'm trying to figure out why it's not working in certain directions, that should give me some starting point, because these do all look correct in every direction. So the only question is why they don't animate when they go across. Or not, that's not the only question. There's also that direction, the thing where they cross the cell boundaries wrong. Why do they not animate when they go across? Okay, this handles when we hit the tick boundary. And so they've finished animating and they go to the next one. The problem that we have is when they start animating, we need to know whether they will be allowed to go next time. And that depends on whether someone else is going to fill those slots. It depends on what's going to be in that slot the next time, which depends on whether someone else is already targeting it. And we don't know that for the rearmost slots. That depends on the guy behind, who may not have simmed yet. Okay, so that'll be a rule for prioritizing when we do the global order, when we figure out what the global sort order is. Okay, so I have to have more fields to belt run. What are we currently at? 3, 4, 5, 6, 7, 8, 9, 10, 14. All right. Well, so is filling. So we set this if somebody is already trying to move into a thing. And that will prevent anyone else from trying to do it. So on the tick, back, let's name it something slightly clearer. Last empty slot empty next tick. Let's make it non-zero, filled next tick. Okay, so under what circumstances can we be filled next tick? Okay, well, first of all, if we do these merges and splits, that will be midway through and all bets are off. So All right, so when we simulate this guy, we'll slot filled next tick of 0. Let's assume it's not filled to start with. Yes, we don't need it here, so let's do it after this. Okay, so we'll start by assuming that it's not filled. But if none of the slots are mobile, then it's going to stay filled. Okay. Then we want to see if we're allowed to move into that next. So all right, so what we think of is that this update, we've just finished animating a something think forward, so it's almost into the next slot. So this is let's document this. Moment. Item len -1, technically ×2 and etc. It's just animated all the way off of the belt. If not. So move item of len -1 out to some other spot. Okay. This len -2 is just migrated all the way to the frontmost, to the farthest position that's still on the belt, i.e. it becomes item of len -1. Now we must check if item of len -1 is allowed to move off the belt over the next long tick, which requires looking at where it's going to land and seeing whether that slot will be free at that point. So, which we already have code to do here. And so we will say int allow new frontmost to move to is 0, 0. So in the same way we copy these, we have to actually check. Well, in this case, we are feeding a new conveyor, so it is in fact VR mobile slots 0. No, sorry, this is allow new frontmost to move. Is if these new, if TB is now allowed to move. Which is if TB, I think it's the same test as above, lots of 0 is greater than 0. Now maybe that maybe TB needs to get updated when we add stuff to TB. Does this change the behavior for whether things can move? Yes, it does. If we push into the middle of a thing, that will prevent a thing from moving. No, no, it never will. So we said we would make this the side attacker wait. This is from the rear anyway, but the side ones we said we would make the side things wait and never interfere with the existing movement. So that never will change the movement in the next tick. So, so item pause. So we need, so if we had a frontmost one, it moved into this position. Wait, oh, that's item base, yeah. Item pause. So we have TV of items, item pause -2, so we want to look one further back. And if that's open, then the new one is allowed to move. But that could be too far back. So that has to be greater than 0. If that's the case, then allow new frontmost to move. What was it called? Yeah, allow new frontmost to move. This is, which side are we doing here? 0. It's allowed to move. And in this case, we don't need to check item push -2 because we've added this, all this to it, which is always at least 2. 3 minus 1 is 2. This should be 0 and this should be 3 actually. So let's just do, let's do that explicitly. So then we say if this -2 is greater than 0, I said that test isn't actually necessary. That should always be true. And plus -2. And wait, these both add +1. But we should be moving. Oh, that's the target side. Yeah, yeah. Right. So 2.type equals 0. And allow new frontmost to move 1 equals 1. Okay, I think that covers it. In some sense, if the other one was allowed to animate forward, it kind of has to go. And we're testing both cases. We're testing, is the one we already animated forward allowed to go? And maybe we should just be recording that. It's like the frontmost one is moving, and then here we just move it off, guaranteed. Otherwise, the animation is going to break, basically, when we fail to move it. Okay, and then we need to duplicate this logic at the bottom, then here. So oh, that one wasn't even the same. Didn't have the -1. Okay. Now, when we get down to here, if allow new front list to move of 0, then the front is guaranteed to move it looks like this is the same as force mobile. Mobile slots, which I was already doing in some cases, but not all the cases. I was only doing it in the forward traveling case. So I think that's, I can just remove force mobile now. If allow new front post to move of 1, else. And I got these backwards. This is the if it's allowed case. If the frontmost is allowed to move, then they're all allowed to move. That is, I believe, the logic. We'll see if I got it right. Item pause. I don't know what you mean by 3x2 versus 2x2, since there's 4 per thing. I think they're appearing after the animation's over or something. It's a little weird how they appear on the thing. Oh, I don't have my clear thing anymore because I just have the other dumb mode now. Okay, well those aren't working. They're not being allowed to move on. What about the, what about across the boundary here? Okay, smooth across the boundary. But those still jump across the boundary. Oops. And that rotation just broke something. Whoa. X off plus faster 0 times f dot len. Okay, so f dot len 1. Yes, f dot len is 1. Dir g dot dir. Yep. X off, f dot y off. I mean, I just computed them right here. How about I used x, not fx? But fx is right here. X, y. Yep. G dot x off. G dot y off. Oh, look, these are garbage. How did G dot x off get to be 255? Split belt raw. A line and num A. Well, I don't have A line anymore, do I? A line was the old f dot line before it got stopped, which we don't know what it was. Well, all I can do is put an assert in. Split belt raw. All right. So the animations all seem correct. So I don't know why it jumps when it goes across. Like, I looked at the animation standalone and they seemed right. So am I moving them to the wrong spots? They should just always go into the 0th slot though, right? For the crossing the boundary case. Yeah, it always goes into the 0th slot. Oh, this is the ordering problem. Right. I still need to globally order them. And until I do that, you are going to see weird stuff like that. So I need to build them in reverse order while testing. Okay, so if we build them in this order, I don't know if that's actually going to... Oh yeah, I will, because this will be an empty list. Okay, and then this, and then this, and then across that. All right, I think these are in the right order. So now if I turn on the creation, yeah, okay, they pop a little. But they're pausing. They're not animating across. So that's wrong on that side at least. But I think this one was still animating. No, it's not. Oh, and it's wrong. So it looks like I just have that test backwards, maybe. It animates when it should be stopped, and it stops when it should be animated. So allow new frontmost to move is if the target is going to be empty. Then we allow the new frontmost to move. And then if allow new frontmost to move is set, then we allow all of them to animate. That seems right. What could do this? All right, well, let's check what's actually happening. Okay, it should be 0 for one of them and 1 for the other. Why are there 3? Oh, because it's just right there. Okay. It's always 0. Okay, one of them is allowing one side to move, but not the other. And let's be our error. Okay, so the one that's straight allows one side to move, but not the other. So let's look at that being computed. That is making a right turn. So it should be this case. All right. Okay, item place is 6. Minus 2 is greater than 0. So we mark that slot as allowed to move. This one should be 0. Item pos is 0. Oh. Yeah. I never handled the other case of that. So, what this is supposed to be is this. If item pos minus 2 is less than 0, then we use that test, else we use TB. Last slot filled next tick of 0. And then on this one, we check that. Otherwise, we check TB last slot. Let's check 1. No, this is sub 0. This is sub 1. I got that backwards. And only one of these needs this. One of these cases can't ever underflow, so I don't actually need to write all this out. But just to be clear, the same logic applies, it just can never happen. All right, now that's a little more plausible. I guess I could also add debugging for this to show what it's thinking. All right, and then yeah, okay. That left one animated in, but now this one incorrectly animated for a while. Yeah, that one's incorrectly animating. So it's not correct. It might be checking the wrong side. Nope, it's not checking either side correctly. Oh, but I might have reordered. They might not even be in the right order anymore. Global hack. Switch back to this mode. Let's check in the other direction. Okay, only one of them animated across, but they both got there. Okay, what about across the boundary? Oh, wait, I did it in the wrong order? Okay, there we go. Oh, that order doesn't even matter. It's the chunk order that matters. So I can't even test that until I really do this for real. Okay. It was clearly wrong. One of them went and the other one didn't. All right, so let's go ahead and get the test case again and look at what's being computed when we do a right turn. Okay. Nothing is trying to move. Okay. Item pos 6, -2, 4. That slot is open. Allow new frontmost to move. Tick filled. No, okay, right. I'm allowed to go if it's not filled. So that was backwards, that test. I don't know if the order of that actually worked. There we go. So they jump when they do that, but I'm fine with that. Oh, and teleported. Or disappeared. I'm not even sure which. I think it's still not computing that correctly. Yeah, it stops and then goes. So I need to figure that out. Oh, and that's computed wrong. And that's computed wrong. So these are either backwards. No, except it's still computing it wrong. So it's just looking at the wrong thing. So right turn. It's still doing it. Okay. No, it claims it's not. Oh, shoot. Okay, why did it think these slots were mobile? Now it's claiming that both of them have some mobile slots, but only one side is actually moving. The order. Okay, that's not the right one. There we go. That's the right one. It's claiming 12 are mobile on one side and 2 are mobile on the other. There's a ton. Right, the 2 at the end are mobile. Yeah, yeah. Oh, and yeah, now it's down to 0. Why does it think 0, 12 are mobile? Oh, I didn't like that. Well, let's just look at allow new frontmost to move because that's set. Why is that set? Which one's set? 0. That's not set. Non-new frontmost to move is 0. Oh, sub-0 is 1. It's a right turn. Oh, that's a left turn. Okay. Item pause 6. BR items. Because this should be TB items. I'm looking at the wrong freaking one. And that one was correct. So I know. I thought I cut and pasted that, but I guess not. Oh yeah, that part I didn't cut and paste. Right, so we were looking at the wrong belt for that turn. So that just meant nothing. Oops. Nope, it's still halted. Oh, too many of them came out once. Where is it that I'm going to want to break? I'm going to want to break up here. It's the right turn. I don't want to break here. Oh, that was interesting. That one animated forward and then got blocked. Okay, and now I want to break. Okay. The right one should not be allowed to move. Yep, and that's got something in it. This one should be 0. Yep. Item possibilize 2, and then last slot filled next tick. Why is last slot filled next tick set? It should be clear. Why would it be? Oh, something did come in right then. Hello, you gonna spawn anything? There we go. I just want to check to make sure I am frame limiting how much ticking happens after I go to the debugger. Okay. Item path to 0. TV last slot filled next tick 0 is set. Why is that set? Is somebody never clearing them? No, we cleared them here. We only set them the last slot is not allowed to animate, so this isn't actually the right test. And BR arrow items of 0 dot type equals 0. Okay, I think this was it. So it's automatically filled if there's an item there and it's not moving. That fills it. Or if somebody else tries to move into it, which is handled elsewhere. I think that's right. All right, well, none of this stuff is going to work unless I do the global ordering properly. So let's look at the global ordering. So what we need to do is visit all of the... So this, instead of being a chunk tick, wants to actually be a block tick. Or bolt tick, rather. So first of all, we need the belt run. Not sure what else we need. So do we reference logic chunk and that other stuff in it? That's what I need to find out. So we're just gonna, I think I do. I think I need to know the coordinates, if nothing else. Yeah, okay, so continue. It's now a return. S, yeah, we need to know the slice. So let's go ahead and keep these. Now we have to commute that. Okay. And then that for m equals 0, m less than logi. What's this loop up here? Oh no, this is already looping over chunks. This is just for m is less than this to be r line. So here br. Logistics belt tick s comma k comma 0 br. Of m. All right, so that should be unchanged. And okay, so to do them in sorted order, we should either pre-store the sorted order or we have to compute it from scratch here every time. So probably we should pre-sort it, but let's just do it this way for now. Type def struct logi slice 8 chunkity 16 this is a belt ref. So then we make our belt refs. This will be tricky. I think we do need to store it. Well, yeah, because it's a little expensive to compute. Just do it the hard way though first to start off. Belt ref br not belt id equals m br not cid equals k br not s slice equals br push belts w. Then we get down to here and we say where I equals 0, I less than SVR len belt refs. And then let's logistics tick belt tick. I think it's belt tick. And that's br by dot slice. Sid br by dot. That's belts, not br. Dot belt ID. Oh, it's not dot belt ID. It's br by dot slice br chunk of br by dot sid. Arrow dot belt runs. That's belt ID. Pretty gross. That was still unchanged. That's still going to just do them in the exact same order. Checking that we've gathered them. So chunk arrow. Yeah. Okay. So this should be unchanged. Yep, okay. So now we can topologically sort them. And the way we do that is what? We have to, we can follow their chains of parent pointers and tag them. Okay, now this is currently actually 16 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16. So if I need a flag bit in here somewhere, I access dir a lot. What do I not access a lot? Z off maybe? No, that's used for calling Target is neighbor. I don't access very much, and it's only 1 bit. So what's the other 1 bit I just wanted to add? Oh, that's a bit. So what we have to do is go through all the belts. And if we're going to push a given belt on the list, we want to push its parent first. But then when we push its parent, we want to push that parent's parent first. What is the way to topologically sort? There's some simple way. I think you depth first search and then go backwards, something like that. So if we push a node on the list, but then we might later visit an ancestor of the start node. There's some kind of easy depth search algorithm. I just can't remember it. Topological search algorithm. Oh, but I don't want to recurse. Of course, it might be cyclic. That's why we have a visited flag as well. Well, this is great English here. We recommend to force the implementation of DFS here. DFS, we start from a vertex. We first print the recursive call, blah, blah. Until we use a temporary stack. We don't print the vertex mean. We first recursive. So I thought there was a simpler one than this. And how do you find the starting place? Only when all of its adjacent vertices are already in stack. Wow, this is such terrible English. Let's see if we can actually find an actual explanation. Which have no incoming edges. We only know about outgoing edges. We don't know about incoming edges. Here we go. That it's already been visited since the beginning of the topological sort. Or the node has no outgoing edges. Is there a difference between temporary mark and regular mark? Yes. That's annoying. For an edge from N to M. Okay, but I only have one edge per node, so that should be okay. All right, so it needs 2 flags. And it does the mark and the unmark in the same state, so it's a three state thing. Rather than 2 separate flags. Enum visited. So yeah, let's call this mark. That pirates off this byte. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16. Okay, good. So unmarked, the temporary, the permanent. Okay, so we go through the list looking for unmarked nodes. So, oh, that's about ref. Yeah, about run equals this. If it's unvisited, unmarked, what does that mean? Oh, but this is recursive. That's the problem. This is recursive, and so we'll potentially traverse the whole belt chain, which I don't really want to do recursively. I don't want to eat up that much stack potentially. It may be unavoidable, right? You maybe have to traverse that far. So all right, well, for now we'll let it do this inefficient way. But now I think this temporary mark does that ever affect this loop? I don't think so, because you untemporary mark once visit return. Like while visit is running, you can temporary mark, but all the temporary marks end and you come back. So this loop only needs to loop one time. Okay, so if br arrow mark equals unmarked, then we run visit. It. If n has a temporary mark, then stop, not a dag. So that's a case that we have. So well, run br equals same thing here. So if br arrow mark equals temporary, now when we marked it temporarily, okay, if right here is when you process node n, this doesn't actually say when to put it. Where does it say to put it on the list? Oh, add n to head of L. Okay, add it. So when n has a temporary mark, we'll return, we'll unmark it, and we'll add it. So we just need to return. It's not a DAG, and we'll break in this case, but that's okay. If you make a cyclic thing and it breaks a little bit, I'm fine with that. As long as it's just breaking the animation. The sim shouldn't break. Mark equals none. Is that what I called it? Am I marked M temporary, M permanent? Am I marked? Then br mark equals M temporary. If br arrow target ID does not equal target unknown, none, target none. We have a target, and we need to find the target. And there was a function I made for getting that, get target chunk. But I actually need to know everything else about it too. Oh, I store offx. No, but I don't want offx. I need the slice. I'm going to technically need the Z as well, I think. I have to add this now. So yeah, I have to call get target chunk. Oh, but that has an output variable, so I can just store it in here. Don't need that. Logi slice capital S and yeah, this just uses address TC S. Get target chunk doesn't need the extra variable. Get target chunk. So TC so slice rough arrow slice X times logi chunk size X rough arrow slice arrow. No wait, that's the base size, right? Chunk. Yeah, okay. Which is exactly what I'm computing here. Times logi chunk size Y, comma TC, not TC, rough arrow sid times logi chunk size Z. Okay. Do I have to pass in something else too? Yep. We have to pass in the logi chunk and then the belt run. Alright, so now we've got the target. So we can construct a belt ref. So target dot apparent. Target dot belt ID equals, that comes out of the belt ref. Target ID. Target dot sid equals the same one as the belt ref, right? And then the slice equals tc dot slice. So for each node, so this is the for loop, we call visit target. Then mark n permanently. And then add node to L. Okay. So I'll have another belt ref array. Missed it. And rather than copy the, well, it's only 8 bytes. Might as well just copy it. Sorted ref. Okay, I think maybe that's right. And then now we just have to draw them all. And we have to reset the sorted array. Sorted ref equals 0. For I equals 0, I less than SVR when sorted ref. What did we have to actually do to build it? I accidentally deleted the line. Logistics belt tick. Belts of I. Sorted ref of I dot slice. Sorted ref of I dot sid. And then br. This replaces belts with sorted ref. And then we have to SVR free. Oh, actually, sorted ref. So set to null here. So we SVR array free belts. And oh, we weren't freeing this when I was running this before. Sorted ref. Okay, so maybe that works. Probably not. Let's actually keep it around so we can debug view it. So so we need to move this up to before the, well, let's just move the renderer down. So have the renderer be last anyway. Didn't use that diagram. Okay, so now we could change this to go in sorted ref order. Well, let's just see if it even runs without hanging. It looks like it hung. Oh, okay. It shouldn't hang at the beginning because there's no data. Okay, that's crossing that, and then if we put one crossing the other way, why is nothing coming out? Am I not taking any of them? I think I'm not taking any of them. I have a bug. Yep, there's no sorted refs. Oh, I never cleared the marks after the first time. I meant to do that here. You set the sorted ref to null before freeing. That's a bug. Thank you. It would just leak memory, and I would never have noticed for a while until I ran it for long enough. Alright, so let's do the crossing test again. Nothing's getting created again. Did I turn it on? Yeah. Oh, that's never getting run still. That's getting run. PR mark 2. Okay, if sorted refs isn't the same length as belts, this unmark will fail. So it might be. Let's just do this at least. Make sure we're clearing them all. Actually, we can just clear them here. CRO BR of M dot mark equals M unmarked. Not unarmed. Unmarked. Alright, we're simulating some of them. Okay. Maybe that somehow was the bug. I don't know why that would be a bug, but alright, so then, yeah, it's still glitching there. But that side at least goes across correctly. Let's clear them. Okay, that moved smoothly across, and that moves smoothly. So it looks like it's moving smoothly across. So that part at least is working. It's just that it does get jammed up at the end. But the moving smoothly across thing, I think, does mean that they're sorting correctly. But that, it just implies there's still a logic bug. It was accessing the wrong one or something. The wrong side, or does that stop when this side fills up? Yeah, it sure seems like it when it's one short of filling up. Yeah, so I don't think that's anything to do with the ordering. I think that's a bug with the logic here. So this is whether the frontmost is allowed to move, and it was on a straight long route. So the one ahead has at least one mobile slot. Maybe it should just be TV. Last slot filled. Next tick. Yeah, that's what it should be. Don't know what exactly, why those would not be the same, but Nope, now this one's doing it. And that one's still doing it. Is this backwards? If it's filled, we don't allow the frontless to move. I shouldn't make it so long. So it won't take as long to fill up. Okay, that one stopped. That one stopped. Yay, that one stopped. What about this one? Yay, okay. There we go. Maybe that's all working. Now I don't know about the ordering stuff at all. What? Thank you. Let's clear it. Start it again. Oh, I saw some weirdness happening down here. Although it does have to break the cycle somewhere. Yeah, there's something weird happening here. Could be where the cycle is. Oh yeah, and then this, that's somebody having the wrong setting for whether they can advance or not. But that was when it filled up, I think. So I'm guessing that this is where the loops breaks when that jumps across. And then as long as this glitch only happens when it fills, And it seemed like it was right before it filled. So maybe I do need to fix that. And there's something getting stuck there. It was incorrect about the status of that. Yeah, that right there isn't detecting this properly. And that one wasn't also. So that's the turning, the right turn, the left side on the right turn isn't detecting that the slot will not be filled next turn. So right turn, which is this one. Okay, if so the frontmost one is allowed to move if that thing is 0 and it's mobile. So TB of mobile slots of 0. Slot is empty. Next tick. Belt. Slot. Slot is greater than or equal to 0. Then that is true if belt items slot dot type 0. No. -2. If the previous slot is empty and the previous slot is moving, the current spot is moving, and either the current spot is moving or the current spot is empty. But the current spot is moving will always be true if the current spot is empty. So we just need that. So B arrow, these should be parenthesized. I'll parenthesize the slot, but not the B. So that's B arrow mobile slots. Side. That slot. It's the side is slot and 1. So that's true if slot -2 is less than the number of mobile slots on that side. Else if it's not filled. I believe that is the correct test. Oh, and we haven't prioritized, we haven't done the tie break that you, that could be a part of why. We haven't done the tie break that the ones that face the same way get priority. I don't know how to do that. No, they don't push like that at all. It's just like what Factorio does, which it's just the lanes just stay totally independent until you use a device that intentionally rearranges the lanes. I mean, and except when you spill at a right angle and then you intentionally dump into a lane. But they don't push each other around with physics-y thing. They only push along the conveyor. Okay, so I think this still isn't quite right because of the lack of that sort. So this may not help. But it was still wrong. Well, slot is empty next tick. tb item pos. The item pos, this one is odd, and so we're testing sub 1, which I believe is correct. So the simple depth first search topological sort isn't going to work because we have a prioritized topological sort. Which is why we maybe need to keep this as a data structure that we keep around instead of recomputing it every tick. Of course, if we update it on every edit, and you edit at a higher rate than the ticks, will actually do more work. Maybe we can we definitely maybe limit the construction so you can only build one thing per tick to make sure that we don't have to do that computation more than once per frame. Obviously, when you're building by hand, you can't, but when you're using blueprints. How do I sort? How do I do that sort? Well, I can traverse along the belt runs that stay in the same direction. Can I just do those first? No, because you only ever have one exit from a given belt run. Belt run. What could you do? Do I need to get back pointers? Once you find the first one, you go pull all the ones that are aligned to it. I could keep track of them. It's another 2 bytes. How many bytes do we actually need, by the way? Just out of curiosity. X off, Y off, and Z off. These are each 32, 32, and 8. So I think it's 5, 5, 3. This is only 2 bits. Len is limited to 5. 1, 2. This is limited to 0 to 32 times 4, 64. So I think that's 7 each. Because you could go, your number can include 64. These are 1 bit each. But then I can't use arrays if I actually pack them. And this is, I've said there can only be 8K. Only can be 4K, so that's 12 bits. And then I have the high values. So it's 12 bits of and then the belts don't actually need to target machines, because if we do the Factorio style thing, you can't actually feed it into something with a belt. You have to transfer from the belt. So we don't actually need to target anything outside of belts. So it's 13 bits. And that has to be the full size. So what is that? $52 bits. So that could be 8 bytes if we packed it. If we leave that at 16, that's 55 bits, I mean. And then we need another target for the input. I wonder how Factorio deals with this. I wonder if they really do this topological sort, because you have to actually incorporate the machines in as well. Maybe. Maybe not. Maybe the machines can just plop things in where there are holes. Or create holes, and it doesn't care about the animation. Or you just do all of them first. You do all the non-belt things, which pull things from belts or put things on belts, and then process on the belts. Maybe that works. I mean, the other thing is that the belt always allocates an items array based on its length. And its length is at least 1, and the items array is at least 8. It's 1. So this is always at least 8 bytes. The thing pointed to by this. Now, do we ever dynamic that? Or because the way we do split, if you did split by always creating a new belt instead of in-place modding them, then those things would be fixed lengths. Anyway, but since this is always 8 bytes at least, let's just spend this. I'm just kind of thinking about a bunch of other things like this. They could store permanently store, when we store the target ID, we could also store which slot we're falling in instead of having to compute it, although computing it is not very expensive. Right, so where do we initialize this? It's a new belt. Just merged it, so its input ID is none. And here we reset them if they were unknown. Except we don't actually look at the unknown case anymore. That's right. We decided we had to do them all. Okay, so if it does that, then dbrj input ID is b, which is I. Right there. Target ID. Is that the only place that I think that's the only place that can specify the target ID to a known value. Yeah. So now we know the input ID. So when we do visit, So how can we do this? How can we force this ordering? Because we don't have the control here. Whenever we visit something, right here, when we add it, we want to immediately add all of its input, the input chain from it. But we'll still need to, and we won't need to visit anything it targets. If equals input ID does not equal target none, then we can't actually use get target chunk because we gotta go in the opposite direction now. Input chunk. So, find the belt position, and we go backwards 1. That gives us the chunk. It should be a different chunk. Should always be a different chunk. And we will use these. Same thing again. Okay, so now we do that, and we say target belt ID equals BR input ID. Target SID equals SID. Target slice equals TC. To immediately visit, no, we want immediately, don't want to visit it, we want to add it. So we do this as a while loop. We push, so we do ref target, and BR equals TC.C. Belt ID. So now BR is updated, but now ref refers to the wrong thing here. Then we make a reference to C here, so C needs to get updated as well. Okay, and now, well, because we're doing that, We can mark it as permanent because we don't need to traverse it anymore. And then here, if PR mark is just temporary, then it hasn't already been added. We add it. I think that works. It's all super gross. Did I make that have... Oh, belt ref has slice, but target... No, target, it's a belt. TC.s, yeah. Okay, maybe that works. So now what I want to do is selected, unselected. Main selected block. Selected block of 3, and then extern int sort order. So then what we want to check is if a given belt run intersects the thing. Now, do we have an intersect test of some kind? I just want to see the numbers. I want to see numbers saying what the sort order is so I can just check if that makes sense or not, because this has gotten a little wonky. Find belt intersection. Yeah, this is does belt intersect. And so we can just use that. What's EX, EY, EZ? That is the target point, right? Oh, but it has to be expressed in relative coordinates. Right, it doesn't add the base coordinates. So we actually have to do that. Is there an easier way to do it? No, I don't think so. Okay, so slice x equals sorted graph of I dot slice, and then this becomes 0. So then int base x, let's do it here. Int base x equals slice x times logi chunk size x. Y int base c equals sorted ref I dot sid times logi chunk size z. Okay. Then we say if does belt intersect, or is it belt does it? Yeah. Okay. Of br of selected block 0 minus base x, selected block 1 minus base x, selected block 2 minus base x, nope, base c, base y. If it does intersect, then sort order equals, let's set it to -1, sort order equals I. So that should capture which one we're looking at. And then we have to actually have a variable for this in sort order, and then we need to draw it. Where do we draw all of our text? Where do we draw all our text? Here it is. So sort order is empty. Sort order. Okay. Who knows if any of that is correct? All right, so then place 2 blocks. Oh, it happened to be across the border. Sort order 0, sort order 2. Okay, that seems odd when there's only 2 things. Sort 0, 3, and 2. What is 1? Do we have the same one in the list more than once? We probably do. No, that points to a different one. Okay, this one and this one. 1 and 3 are the same. So 1 and 3 have gotten added twice. 1 and 3 has gotten added. Oh, well. Now who knows? No, they all had the same CID. So it was still duplicate. That and that were duplicates. Okay, right, so 3, 0, 2. So this is both 3 and 1. So the question is, why is this one getting added twice? Oh, why can't you delete this? Start ref. Ref. Okay, is anything getting forced by this? Yes, that's one of the ones that's getting duplicated. But we're setting it to marked permanent, so it shouldn't be able to get added here. Unless it were getting added again here. But it shouldn't be able to. If br mark is impermanent, then we just have to break. Because we assume that should just never happen though. You'd have to add those, then dump out to. Yeah, I don't see how that could happen. let's see if that's what it was. Zero, one. 0, 1, 2. So those did not happen in the correct order. That got pushed. That's 0. Okay. There's nothing there. So this one's getting pushed. Oh. I set the input ID incorrectly. I'm only allowed to set the input ID if they have the same direction. There we go. Which is probably why I was getting that other case that I thought should never happen. Zero, one. 0, 1, 2. Still not happening in the right order. All right, let's check. Traversal. Visit. Oh, I went by visit. Okay. Okay, I'm never hitting this case. I'm hitting this case. So it might not be finding the right chunk. C.S, and then do we already have an old slice? Rough slice. It's in a different spot, so that's good. Pointing in the right direction. Why is it already marked? What is it called? Sorted ref. There's only one item in the list. So I just pushed the very first thing. Because I'm looking at VR, which I have not evaluated. That's why. I need to mark the target. I haven't computed that. I compute that here. All right. I'm only on 10 hours about today. I didn't go to work today, so we go bump, 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 bump. This one's sort order 0. This one's sort order 1. Turn that. This is sort order 2. 1, 2. Do this one. Do this one. Do this one. Do this one. Turn back to this. Okay, now let's see what we got. This is 0. This should be 1. Okay, good. Then this could be anything. That's 3, so maybe this is 2. So then this one, then this one, then this one, then this one. Okay. Where's another border? Here's a border. Okay, thank you. Okay, so 0. Okay, so this should be 0, then this will be 1. Apparently this is 2, so this better be 3. Good. Okay, maybe that's all working. Oops. Let's actually go ahead and turn that. Oh, shoot. I hit a bug, and my R... Oh, okay. It did go in instead of dying. Okay, so this assert broke, but these asserts didn't break. So this was that assert I hit before that I couldn't figure out why it would happen. Yeah, because GX off is totally bogus. X, Y, dir. Oh, I see. If you try to split a belt, the start point can be in the next thing. Because this split can be empty. So g.len should be, yeah, g.len is empty. So then these are bogus. So it's actually, we just don't bother doing the test. We could try to also like store these to a signed variable. In fact, we could just make x off and y off signed. But can I continue? Oh, I didn't continue on. I didn't even mean to have it on. How convenient. Okay, so then start populating it. All right. So then I'm going to fraps and capture this and post it as a current progress. Oops. Stupid phantom mouse clicks. Okay. Voila. All right, that is it. And what was the other thing? Oh. All right, so thanks for watching, and I will post that. I'm eventually going to post these streams, but first I'm going to just post that Wolfraps video I just did. All right, so thanks for watching. See ya. Bye-bye.